Hello, how are you? Can you hear me? Let me know if the sound is good. I'm trying to fix this. So give me 1 second. Um, Trying to get this display. Okay, good. So you can hear me. So I'm just trying to get the display capture here, but just having a little trouble. Uh, I'm guessing if I just make it. Alright, I'm gonna open up like a OneNote and just make a window capture then. Alright. So I'll just make it window capture, and then I'll make it Google Chrome. Well, okay. Alright, so if I make it Google Chrome, then I guess you can see this. Yeah, okay, so let's see. Let me see what's up with this. Yeah, so I need to make sure that, yeah, there you go. That's what I wanted to make. Alright, so the thing is, you can see my part of my screen actually. You can only see the one window. So what I'm trying to do is make a display capture, but it's not does not seem to work. Um, okay, I'm not sure if you can see this. So just give me 1 second. So I'll just make it, I guess, window capture too. Yeah, that works. All right, so yeah, so okay, no problem. So we can do this, and then I'll just use this website to upload the sketch. So I'll upload this stuff that we're gonna go over. So, all right. I'm gonna have your comments here on my phone so that if you have any questions, then you can ask. Okay, so Professor Joe Pat. All right, so here's the thing. Um, one of the guys that like the one person that contacted me has an Arabic name that I couldn't read, so I'm not sure what his name is. Um, so it was in Arab, like it was in Arabic. It was written in Arabic. So, but he suggested that I should make this video for you all who are interested in reviewing for the Calculus 111 exam. So I said why not, right? So why not help you out? And so here is, for example, one of the oh Safila. Okay, Safila is that you, right? Okay, so then thank you. Yeah, thank you for suggesting this review. And so I'm gonna pull up the problems that you sent me. Okay, so here are some of the problems that you suggested we should go over. And that way, we can get started with something. Okay, so yeah, so are you guys ready for this exam? So how do you feel overall? Is it, easy, intimidating? What do you think? Huh? Can't be too hard, right? All right, so actually, let me make my face smaller because it's probably gonna interfere with whatever I do. So I'll just make it a little bit smaller. You're failing. Oh no, that's not good news. You need a 70 to pass the course. Yeah, this is the truth. Truth is that mathematics is not easy, man. Mathematics requires you to do a lot of work. It takes a lot of effort for you to actually grasp mathematical concepts. Not everybody gets this just like that. So you have to put it on a particular amount of work so that you can get better at it. Yeah, I mean, honestly, if you want my thoughts about this, I'll tell you, it's not a great day. It's not a great time to be in college. And I decided that I should, just take it easy for now, take set some time aside to think about what I'm going to do. And just like get some stability financially because right now I'm not doing financially great. So that's why it's one of the reasons for why I actually, withdrew from my courses because I just can't stand the debt increasing, right? It mathematically doesn't make sense to get your debt increasing and then having to work for so long afterwards to pay it off. So I honestly don't like the idea. I mean, of course, it makes sense. You're going to pay it off after some time, but it's a liability, right? It's going to stay there for some time. And I don't like that. So I want to make sure I have some financial cushion. Um, all right, no problem. So let's get started with these problems. And so this is calculus 111. So here is one of the problems. Okay, hopefully you can see it. Not sure how well you can see that. Um, Let me just zoom in a little more. Okay, so here's the problem. It says that, the line that is tangent to the curve y equals a square root of 2x at x equals 2 intersects the line, it intersects the x-axis at x equals, so we're looking for the x value, right? Where we have essentially a tangent line at the curve square root of 2x, right? At x equals 2. And so what we're looking for is essentially where, right, we're going to have this point of tangents, right? So, okay, so then, I mean, so what will be the first suggestion to solve this problem? So what do you guys think would be a good suggestion for this problem? You have a line that is tangent to this curve square root of 2x. And if you want to get a sketch of it, it kind of looks like this. So the square root of 2x is like this. Okay, that's the square root of 2x. So take the derivative, right? Yeah, take the derivative. Because if you take the derivative, you know where the tangent is at x equals 2. At x equals 2, you can find where the tangent is. So easily, you can calculate the derivative at that point, and that's going to give you the slope at that value. So precisely, dy over dx is equal to d over dx of the square root of 2x. Okay? Now, one thing and then set x equals to 2, right? Right, so, so because you want to see where this tangent line intersects the x-axis. So you want to set x equals to 2 for that tangent line, right? Because we're looking for the tangent line. So then take the derivative. The derivative, remember, is kind of like taking the derivative of a polynomial or some number x to the n. And in this case, you have pretty much a root, right? So it's going to be the square root of 2 times x to the 1/2. You just subtract 1 from the exponent, divide by the exponent, right? So then you should get so 1 over. So you got to take the derivative of the inside first, right? You remember that? Because there's a chain rule. So you take the derivative of the inside first, you get 2, right? So it's going to be 1 times 2 divided by 2 times the square root of 2x. Okay, so don't forget that the chain rule is important here, because over here the function the square root of u is a composite function, right? This is a composite function g of u, right, where g is essentially a function of x, right? So g of x, and this is just the square root of x, and u is just some other function. So like, oh, and never mind, I meant to say g of u is this, so just forget that. And u is a function of x, right? So it's just a function of x, and in this case it's 2x. So you take the derivative of u first, so it's u prime times the derivative of g. That's why I put 2 first. The derivative of 2x is 2, divided by 2 times square root of 2x. Cancel out the 2, easy peasy. And then that's the derivative. This is dy over dx. Okay, and then what's going to be the slope? Well, the slope at x equals 2 is when the derivative has the x value, x equals 2. So 1 over the square root of 2 times 2, which is 4, right? So it's going to be 1 half. All right, that's going to be the slope m of the line. It's going to be a half. Now we need to find the slope. We already found the slope, so we need to find the line, right? So we need to find the tangent line, the equation of the tangent line, and it's usually easiest to get it in the point slope form once you have a point, right? Because well, first you need to find the y value at this point, right? At this point, you got to know that y, if x equals 2, then y is going to be 2, right? Because it's going to be 2 times 2 is 4, square root of 4 is 2. So 2, 2 is the point. And if we know the point, then it's very easy to write the equation of the tangent line in point slope form, which is y minus y1 equals m times x minus x1. Okay. So if somebody asks, the point is 0,2. Well, think about it. So yeah, the point is, yeah, you're right. The one we're looking for is where x equals 0, right? So where x equals 0, but first we'll need to think about where x crosses the x. So where the line, this line that we just we're talking about, is going to cross the x-axis. Well, of course, in order to do that, we need to find the actual equation. So it's going to be y minus y1, and then we found that the y value of that particular point of tangency is 2. So y minus 2 equals to a half, which is the slope. It was found earlier, multiplied by x minus x1. Okay, so that's going to be x minus 2. This is the line, right? This is the equation of the line. What do you do next? Well, think about it. The line, this is the equation of the line, and the line is going to keep on going like this, such a way that it intersects the x-axis, right? We're basically finding the x-intercept. Finding the x-intercept. So, okay, so now you see it, right? Yeah, so if you want to find the x-intercept, what do you got to do? You got to do y equals 0. So if y equals 0, this goes away. Multiply by 2, you get minus 4 equals x minus 2. Add 2 on both sides, get x equals negative 2. So the answer choice should be the third one. Excuse me, the fourth one, negative 2. Yeah, so this is tangent lines. So just remember to always have make a sketch if you need to, because sometimes it's kind of hard to visualize this stuff. Even in 1D, even in one single variable calculus, sometimes it's difficult to visualize what's happening. So like right now, I'm studying 3-dimensional calculus on my own, right? Because I'm no longer taking the course, so I do it at my own pace. But sometimes it's so hard to visualize stuff in 3D that I actually need to make a sketch. I actually need to go to a 3D grapher, put it on the grapher, see how it looks like, and see why it makes sense, right? This is the essence. The essence of calculus is to make complicated problems simple. Okay, now let's go to the next one. So the next suggested problem for review. Of course, guys, if you have anything, right, any problems in particular from like an exam review or something like that, just drop the link down below on the comments, right? Just drop it down. I'll take a look at it. Just tell me which problems ahead of time, right? And then I'll look at it so that you can, get the most out of this. So just so you know, I'm going to be done at 9, right? So make the most out of this. At 9 p.m. I'm done. But of course, we can. I really don't know when the exam is. Oh yeah, yeah, no problem. I mean, yeah, I have experience with this. So if you make, I can make up a question, no problem. But so let's take a look at this one. So for this one, my dears, you have to do L'Hopital's rule because when you have direct substitution, you get cosine of 0 times sine square of 0 divided by 0. This is an indeterminate form limit. When you have these kinds of limits, or something like infinity times 0, or something like infinity over infinity, this is called indeterminate, right? Indeterminate form. The exam is Wednesday. Okay. So yeah, no problem. So I could do another review if you want tomorrow. I mean, I'm gonna be free. So let me just check real quick. Look, I'm gonna be free at at around the same time, like at 8 p.m. Hopefully nobody's gonna schedule a session with me because I'm working like I work as a tutor. So sometimes people schedule sessions, but we could do something at around 8 or maybe 10 p.m. Hopefully that works, right? Yeah, no problem. Physics one, all of that kind of stuff is yeah. Oh, okay. So somebody said, yeah, quick review of fundamental theorem of calculus or area below curves. So yeah, let's just get this out of the way. This for problem 15. So an indeterminate form, right? When you do indeterminate form, you gotta make sure you can do two things. You can change the expression algebraically. You manipulate the expression in such a way that it's no longer indeterminate form. But that really is it's kind of difficult sometimes. So it's recommended that you do L'Hopital's rule. And L'Hopital's rule is that you take the derivative of the top function if it's g of x over f of x, and you take the limit as x goes to 0. Just this is equal to the limit as x goes to 0 of g prime over f prime. So take the derivative top and bottom. You see, notice on the top you gotta do a double chain rule, and you gotta do a product rule. Actually do double chain rule for the sine and do one chain rule for the cosine, do the product rule for both, and then you're gonna do just once the power rule for the bottom part, and you get the answer. So like if we just do it really quickly, let's see, we're gonna get, so it's gonna be 3, so the derivative of the inside, right, times the outside, so the derivative of cosine is gonna be negative sine 3x, and then times the second function, sine squared 2x, plus, okay. Okay. So you said that these topics won't be on the exam. Actually, thank you very much. That's a very good point, right? So remember, Safila, like Pamela said, the professor said these topics will not be on the exam. So you might not have to worry about that. But if it comes up, a limit like this, just make sure you know how to do it, right? Okay. So, yeah, just calculate the limit, do the product rule, do this stuff, and then you should get 4, right? Okay, so just do that. Now let's do the next one. Fundamental theorem of calculus. Somebody mentioned it. Yeah, L'Hopital's. This is L'Hopital's rule. Yeah. So, but like Pamela said, there might not be, right, something like that on the exam, which is strange, right? But don't worry, it's probably going to come up as like a part of a problem, right? A different problem, so a different topic. It always comes up. L'Hopital's rule is very fundamental, very important to know. So don't forget it. Yeah. Oh, you want me to do the problem? Yeah, no problem. So let's go back. Yeah, so let's finish it up. So plus, we have derivative of the outside, right? Yeah. So okay, so there will be L'Hopital's. Okay, so let's finish it up. So then we do the derivative of the second function, which is sine squared of 2x times the first function. So just write down like cosine of 3x first, right? Disregard this scribbles here. And then times the derivative of, right, the second function. So now you got to do the chain rule. So you have 2x inside, and you also have a sine of 2x inside, and you have a squared, right? So it's kind of like 3 functions there. So now it's going to be, the derivative of the inside is going to be 2, right? The derivative of 2x is 2, times the derivative of sine of 2x is going to be cosine, right? So cosine of 2x, and then the derivative of u squared is just the power rule, bring down the 2, so multiply by 2, and then multiply by the original. So this one is something important to remember. Okay, chain rule and product rule. Divide everything by the derivative of the bottom part, 2x. Okay, so now you can simplify a little bit, right? So okay, so then yeah, you can simplify a little bit, and then you're gonna get. So let's see what we're gonna get. On the left side, if we plug in sine, right, you should get 0, right? So you should get 0 because sine of 0 is 0. And on the right side, you still get sine of 0 is equal to 0, right? So you still get essentially you still get 0. So all right. So then you still have to do another L'Hopital's rule. So this one can get a little bit tedious. This one can get tedious. So try this one on your own since we're very short on time, and do another one L'Hopital's rule, and eventually you should end up with an answer. Yeah, you need to do it again, right? If you still get 0, right? If you substitute for x equals 0, clearly this is 0 over 0. It's again indeterminate. Now notice that if you take another derivative, right, the bottom part is going to be 2. This is going to be 2. And then you can visualize this to become a sum and a product of sines and cosines. But eventually there's going to be one of them that's going to be a cosine alone, right? Or maybe a couple of cosines, and then they become cosine squared. And so what that means that it's going to be essentially, right, it's going to be when x equals 0 for cosine, you actually get 1. So at some point you're going to get a cosine somewhere. Everything else is going to cancel. You're going to go away. Yeah. All right. Yeah. So yeah. Okay. If you substitute sine squared x with 1 minus cosine squared, it will be easier. Okay. Thank you. Yeah. That actually is a good suggestion. Yeah, because essentially, if you do that already, then you can essentially get this done in a couple of steps. So if it's cosine of 3x and then sine 1 minus cosine, then it's going to be just cosines, and so you will have to do the chain rule here and then the product rule. But then of course you would need to separate this a little bit, right? So you would need to change this into something like cosine, right? Cosine of 3x divided by x squared, and then minus cosine squared of 2x divided by x squared, right? And then you take the derivatives. You know that the sum of the limits is going to be the same, right? The limit of this is just, you can split it up. You can do anything to the limits. So, okay. Oh, the common exams are open-ended. All right. So, yeah. And then you can just calculate the limit, right? So if you basically you take the derivative twice for the first one, you're gonna go back to the cosine, right? So you see, you take the derivative of cosine is negative sine, and then again it's gonna be negative cosine. So this becomes negative. So negative cosine is going to be 3 times 3, right? So it's going to be 9 cosine of 3x. And then on the bottom, you take 2 and then 2. So it's going to be 2 only. So this becomes 0. And then cosine of 0 is 1. So then minus, right? Minus. Oh, and don't forget this is a negative, right? Because you take the derivative of cosine is negative sine, then negative cosine. And then minus the derivative of this is going to be 2 times 2 cosine 2x. And then the derivative of cosine, of course, is negative sine. So this becomes positive, and then sine 2x, right? And then divided by 2x. And then you take another derivative, right? So you would have to do the product rule again. Yeah. So yeah, no. If you have 4 minutes per question, yeah, you gotta work fast. So then just take the derivative of this again, right? So then you gotta do the product rule again. So notice one of these twos go away, and so you're gonna get, right? So take the derivative of this again. So it's just gonna be 2 times 2 is 4, and then it's gonna be minus sine 2x, and then sine of 2x, right? And then, so you're going to have plus, so plus 2, and then times cosine of 2x. And then over here, the derivative of sine is, the sine of 2x is going to be 2 times. So 2 times cosine, right? Cosine 2x. So clearly this becomes, 4 over here. And so you should be able to get the answer. Okay, because this is 4 over 2, right? So once you get the derivative of that, so you should get answer choice 4. Okay. Yeah, no, I that's why I didn't. Yeah, so let's go to the fundamental theorem of calculus. Fundamental theorem of calculus, okay, is very simple. First part of the fundamental theorem of calculus says that, okay, the antiderivative, right? So that the antiderivative of some function is basically the opposite, right? So do you guys remember the first part? So the first part of the fundamental theorem of calculus. And then the second part, so the second part is this one. It's pretty much, so the second part is that the derivative, right? The derivative of the integral is just the function itself, right? So this is just the function itself. So the derivative of the integral is the function itself. I think the first part was just differentiating or just integrating. I think it was just integrating. Yeah, it's just like integral of f of x dx. It's just f of x, I guess 1 or 1 minus f of x 0 if this has x0 to x1, and then and then otherwise if it's not a definite integral, it's just, if it's indefinite, it's integral of f of x dx is just f of x plus c. And the second part is the derivative of the function is the derivative of the integral of the function is just the function itself. Suggests that integrals and derivatives are opposite functions, right? They are inverse functions, which tells you that if adding is the opposite of adding is subtracting and multiplying is dividing, right? It's just like taking a logarithm or raising it to the power of the logarithm, or in this case, it's going to be taking the derivative is the same. The opposite is going to be the integral. Okay, opposite operations. They are opposite operations. So, okay. Now so just take the basically in this problem, I am pretty sure it's suggesting to take the derivative, right? So find y prime. So this is just d over dx, right, of the integral from square root of 3 to x cubed cosine of t squared dt. And in this particular integral, you have a function in the upper bound. So when you have functions in the upper or lower bounds, all you gotta do is just multiply by the derivative of the upper or lower bound. So take the derivative of this, it's gonna be the function itself. So just substitute for the upper bound. The derivative of a constant is 0. So then this is gonna give you, the derivative of the upper bound, which is 3x squared, right, times the original function cosine of t squared. So substitute t for the upper bound, so it's x cubed squared, right? So it's x cubed squared, and then minus 0 because the derivative of constant is 0. So then, the final answer for this is just going to be 3x squared, right? 3x squared, and then cosine of x to the 3 times 2 is 6, and that will be the answer. So this will be the function. Okay, so somebody suggested something else. Okay, so do you have any other suggestions, any problem suggestions that you want to take a look at? All right, so do you guys know how to do optimization problems? Is that going to be on the exam? Optimization problems, like for example, if you have a, like a box, right? Let's say you have a box, area below curves. If you have any examples. Oh, okay. Yeah, so let's take a look at the area below curves. One simple example, is for example, some x squared negative x squared plus 2 is f of x. And let's say you have, x squared, right, on the other side is g of x. So then the other function should look something like this. Okay, and then you're asked to find the area between the two curves, right? River with 3 volts. Yeah. For optimization problems. Yeah. So optimization problems actually are toughest, I think, on the Calculus 111 exam. Optimization and related rates are probably the toughest ones. But yeah. So no problems, Safila. And then okay. So then for this one, it's very easy. All you gotta do is you gotta know that you have to do an integral, right? So you gotta integrate either with respect to x or with respect to y. In this case, if the subintervals are with respect to x, so that means that they're perpendicular to the x-axis, then you're integrating with respect to x. How do you find the function? Well, it's basically the difference. So this distance is going to be the function that we are trying to find the area of, right? So we're going to add up all those distances, okay, from this point of intersection to this point. So first, of course, naturally, you will need to find the points of intersection by setting the two functions equal to each other. So like g of x equals to f of x. And at those points of intersection, then we have that x squared equals negative x squared plus 2. Add, x squared on both sides. And then you have 2x squared equals to 2. So then that means that x equals plus or minus 1. So I try to make the numbers easy so that it's not too complicated, right? So then it's going to be, this is x equals negative 1, and this is x equals 1. So once you know what the boundaries are, it's going to be simpler because it's going to be an integral from negative 1 to 1 of whatever the top function is, right? So look at the top function. The top function over here is, we call it f of x. And then the bottom function over here, okay, is g of x. So what you got to do is you got to do the top function minus bottom function. So it's going to be f of x is the top one, right? So it's going to be f of x minus g of x and then dx, right? To find the area bounded by the two curves, you do that. And then one important thing to take a look at is the following. So let's just substitute this stuff in. So integral from negative 1 to 1. F of x is 2 minus x squared, and then g of x is x squared. So this is the same as the integral from negative 1 to 1, 2 minus 2 x squared. Notice you can take out a 2 outside, right? So somebody asks, how do we find which function is the top? If there's no graph given, I guess make a quick graph. Yeah, so, right, make a quick graph. Yeah, so you got to make a quick sketch. You got to know that so for quadratics, if the function is negative, right, like this one, is a negative quadratic. So the leading term of the polynomial is negative. It's going to go downwards, right? Concavity is going to go down. And that's probably going to be the top function. But like, somebody said, it's always good to make a quick sketch. Yeah, no, they don't really make it too complicated, honestly. I think the whole point of this is to understand what's happening, right? It's to understand why you're adding up these areas or how you're getting to the setup of the problem. So now let's analyze this integral a little bit. So just take out a 2, you get 2 times integral from negative 1 to 1 of 1 minus x squared dx. Now, one thing to notice is that if the function is even, right, in this case the function is even because if you substitute negative x into the function, the integrand, right, this is the integrand, then it means that if you get back to the same function, you know that that's a symmetrical function. If it has symmetry, right, if it's symmetrical about the y-axis, if it's a function that's symmetrical about the y-axis, then what that tells you is that the integral from the right, from 0 to the left portion is equal to the integral from 0 to the right portion. And that's clearly, illustrated on these curves, right? So like on the left side, you know that this area over here must be equal to this area. So you got to take advantage of symmetry by making the calculation a little bit simpler. So you can change the bounds of integration, and you can make this 2 times the integral from 0 to 1 of 1 minus x squared. right? It's gonna come in quick on the exam. If you know the integrand is even, do it immediately, no second thought. But if it's not even, if it's neither, or if it's odd, don't do it. So you gotta do it the way it is. So then you so just integrate it with respect to x. So it's gonna be 4 times x minus x cubed over 3 from 0 to 1, right? So 4 times 1 minus 1/3. Okay, this becomes 3 over 3. So it's going to be 2/3 times 4, 8/3. It's going to be the area. Okay. So yeah, it's a good thing to remember because you saw how the calculation became so much simpler because you didn't have to worry about the -1 anymore. If you know it's even, just take advantage of it, right? Sometimes the functions might be shifted a little bit to the right or to the left, and in that case you gotta be careful. So you gotta know how to spot even, odd, or neither functions. Okay, so good. We're doing good. We got like 15 minutes. So let's see. Okay, what about the classical optimization problem for the box? Did you guys do that? You probably did it because of the textbook. Textbook covers it. It's like the one where you have a box and let's say that the company only, so like you want to make a box whose dimensions of the cardboard is going to be, let's say, 2 inches, I don't know, by 1 inch, just to make this simple. 2 inches by 1 inch. So essentially, no, actually, let me make this a little bit bigger. So like, let's say 3 inches by 2 inches. And so essentially what you want to do, what you're asked to do is to maximize the volume, right? Make a box out of this so that you have a maximum volume and you can fit more books in it. So yeah, 8/3 was the answer. You want to go back? Look, it's right here. 8/3 was the answer. Yeah. Okay. So yeah, just gotta remember those little tricks. Now for this one, the optimization problem, you just gotta know. Okay, the reason for why optimization problems are more difficult than all other problems is because you actually have to think. Okay, so you actually have to think about the problem itself, and you have to bring your own reasoning, your own logic, right? Common sense. You're gonna bring some common sense into the problem. Okay, because a lot of times, you're gonna stumble upon different relationships. And in this one, for example, it's not too complicated. You just gotta minimize, right, the volume by cutting up the 4 corners, right? You cut up the 4 corners to get the height, right? Because you're finding a volume. You only have 2 dimensions. So what do you gotta do? You gotta make a third dimension. And to make it simple, you always make it the same for all. So like this is height h, height h. This is h, 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 h. You cut it by h. Cut the corners by h. Try to maximize the area so you can fit more books in it. So then what you do is you say, okay, well, now I have an actual box. If you imagine that you're going to fold it, right? You're going to fold the edges into a full box, then you can think of it as a 3-dimensional shape. So then the area, the volume is going to be this dimension times the height h. So the top dimension is going to be 3 minus 2 times h, right? You have 2 h's that you're going to take off. So it's going to be 3 minus 2h. This side is going to be 2 minus 2h. And then the height, of course, of the box, once you fold it, it's going to be 1h. And this will give you the volume. Once you have the setup, everything becomes easier because all you got to do is just the calculus. You got to do the math. Over here, you could think of this. Of course, expanding it will be better. So just expand it. So 3 times 2 is 6, minus 6h, and then minus 4h, plus 4h squared, all of that times h. Just expand everything out of like terms, and then find the derivative, right? So v is equal to 6h, right, minus 10h squared plus 4h cubed. Now you have your volume function. So all you gotta do now is take a derivative to maximize or minimize, which will be rare, the volume. Sometimes you want to minimize, sometimes you want to maximize. That depends on the context of the problem. Hey, Guapo Zach, I'm not sure. Yeah, this is a math class. I'm not sure if you're lost. You're probably not here for the same reason as everybody else. You're probably here for gaming or something like that, right? Okay, well, let's keep doing this. So you maximize the volume, right? So you you want to find what values of h. So basically, how much you're going to cut the box up on those four corners, so that you actually get, a maximum value. It makes sense that you have to have some function, since it's a cubic polynomial, once you get the derivative. So this is dv dt, dv dh, because we're differentiating with respect to the height. So we're maximizing the volume with respect to the height. So this is 6 minus 20h plus 12h squared. Of course, the same drill, right? First derivative test, find the critical point, set it equal to 0. Set it equal to 0. Find where the slope of the tangent line is 0. So find the, now this is such a nice point for me to teach you something that nobody ever told you. Maybe one or two might know, but it's a secret weapon that you should know about, so that it takes less time for you to calculate the zeros. Because remember, on the Calculus 111 exam, there's no calculator whatsoever. So you gotta be quick and swift when you're doing these problems, right? You gotta be quick with the arithmetic, you gotta be quick with the algebra, and you have to know the calculus. So the calculus is, of course, the main topic here. So what you gotta do here, of course, you can factor out common factor, right? So like, for example, a 2, right? You can factor out a 2 here. So it's going to be 3 minus 10h plus 6h squared. Now, what I'm talking about is, this is a really ugly function to find the zeros of, right? So usually you want to resort to the quadratic formula, right? So that's usually what people do. They do x equals negative b plus or minus the square root of b squared minus 4ac divided by 2 times a. Of course, very effective at doing it, very accurate. It's perfect. It's a formula, right? It works. I'm not saying anything wrong about it. But what I'm going to tell you is that sometimes it might get you into trouble, because, for example, in this example, we have huge numbers. These numbers are really ugly when they come into the discriminant. So I'm going to show you one of the forms of the quadratic formula that nobody ever told you, or at least most of you. So this is called the half quadratic formula. And the half quadratic formula is an equivalent of the quadratic formula. And this is negative h plus or minus the square root of h squared minus ac divided by 8. It's a much simpler form of the quadratic formula, and I'm going to tell you the origin. The regular quadratic formula comes from the form ax squared plus bx plus c. This is the regular quadratic formula form. The half quadratic formula runs on the principle, on the idea that if b is even, I can split it in half, right? I can split it in 2. So split b into 2. If b is split into 2, I am going to call it h. If I call it h, then I know that b is 2h. So just substitute it into the form ax squared plus 2h x plus c equals 0. This is the half quadratic formula form of this equation. And it is left to you as an exercise to solve, to derive this half quadratic formula, because we're running short on time. I could show you later if you want, in another session. But this, once you substitute 2h into this regular form, you get this half quadratic. Half quadratic is so nice, because all you gotta do here is half 10. Half of 10 is 5, so it's just minus 5. So x half is minus 5 plus or minus square root of 25 minus a is 6, c is 3, divided by 8, 6. That's it. And now you see the radical expression inside the radical is so much nicer. It's better, way better than the regular quadratic formula, because you are able to reduce the expression. Okay. So yeah, you gotta do this quick, right? Like right now, I'm stopping. I'm actually trying to explain to you, trying to show you some tricks, because you gotta know. It's just a matter of practice to get it, get it quickly. So this is minus 5 plus or minus square root of 6 times 3 is 18. 25 minus 18, it's gonna be 7, right? So square root of 7 divided by 6. 2 steps, right? Half quadratic formula. It's 2 steps. Who blames you? You can use it, right? You just gotta make sure that you state what it is and what is the form, right? Because maybe professors might not like it. Some professors are assholes, and they'll tell you like, "Oh, you're not supposed to use this. You have to use the regular form." So I don't like that. I feel like you gotta use what you know and if you know some tricks, you definitely should be able to use it on the exam, right? Why not? So then you have two zeros here. How do you maximize? How do you find which one is the maximum, which one is the minimum? Very easy. You plug them into a line over here. You put the ones that's the 1 0 that is going to be the most. Oh, okay, my bad. I made a little mistake. I don't know if you caught it. B is -10, so half of -10 is -5. But remember, this is -8, so it's +5 here, +5, right? So it's just that thing. It's just a sign. So +5. Okay, so +5. So how do you find what's the max, what's the min? Very easy. Plug them onto the number line. So so and then yeah, and so then you're gonna have the most negative number, right? The smallest one is gonna be 5 minus square root of 7 over 6, and the biggest number is gonna be 5 plus square root of 7 over 6. Now you have to analyze the sign of the derivative. If you know that the function is positive, right? It's concave up because the second derivative is positive, but then you know it's gonna look something like this, right? It's gonna look like that. So that means over here is positive, over here is negative, and over here is positive. When it's positive, when the derivative is positive, then it's increasing and then decreasing, right? And then when it's negative, going from negative to positive, is decreasing and then increasing. So then the maximum is over here, the local max. So at the height, when the height is cut up into 5 minus square root of 7 over 6, you have a max volume. Okay, so that's an optimization problem. That's an optimization problem. A classic, right? Oh, so somebody asked, okay, what's the secret? It's less time, more failure, hence more money. I mean, yeah, it's the business. I like that idea. I want to make a university for myself. Enlighten me. Facts. Well, of course. So how do you charge? How much do you charge for tutoring? I charge $20 an hour. Don't forget, 66% of course are exempt. Yeah, so that's true. 66% of courses are exams, and you know, really, that's how colleges have been doing it for more than a couple hundred years, right? So 200 years maybe. So it's been a while, and I think it's time for some change. I think it's time for change, for education to change. It's time for it's time for the way how people think they can be successful to change, right? Because it's not just about getting a college degree and then going off to finding a good paying job. You have to also think for yourself, have your own thoughts, and think about it, right? Think about what you're doing and why you're doing. Always remember to question everything, especially if you're a STEM in the STEM field. If you're in the STEM field, you're a scientist, and if you're a true scientist, you question the truths, even if they're truths. You question them and you prove them empirically. You try them empirically. You try to prove them empirically, even if they're truths. If you're a scientist, that's true, and so that's why you have to question everything. So, yeah, paper doesn't define. I mean, of course, yeah, it's I mean, honestly, when I started my YouTube channel, I just did it for fun, right? I didn't have any high expectations. I didn't think it was going to be a huge thing because I already knew, like, people like the Organic Chemistry Tutor, 3 Blue 1 Brown, all of those great math channels that I love, that I watch all the time, physics channels. They are way ahead of me, right? So the thing is, I cannot keep on doing the same thing they're doing, right? It doesn't make sense. I'm going to be way behind them if I keep trying the same thing that they've been doing. So what do I have to do? I gotta try a different way to teach. I gotta try something more creative, something of my own right making. So organic chemistry tutors more than SALCAN. Yeah, I mean, honestly, I like both of them, but SALCAN is it's just really straightforward, and it's just more fragmented, right? It's more specific. But I guess both of them are good, right? And yeah, so the organic chemistry tutors, I recommend it. He's very good at explaining it, very good at making it sound very simple. So simplicity is always important, especially in calculus, right? Calculus is about making difficult problems simpler. And all of this stuff that we learned, derivatives, all of this was impossible to do, right? Like this at this speed back in the in the ancient times when Archimedes, for example, tried to figure out the quadrature of the parabola. He tried to figure out the area, right, between two curves. Like he literally did what we were just trying to do, but with more advanced, with less advanced methods. Excuse me. He was basically saying, okay, I have a parabola, and I want to find what's going to be the area in between this line and the parabola. And he actually did it. Believe it or not, he did it. He did it, and I mean, it's his genius that did it. He just did it by approximating it with triangles, drawing triangles smaller every time, right? And adding up the area after you split everything up. So, um, yeah, yeah, that's true. I agree. Yeah, so it really depends. Oh, my major, somebody's asked for my major. My major was or is mathematics, applied mathematics, and applied physics. So I am a double major, right? The double major for mathematics and physics. And I'm still interested in both subjects. I studied them on my own time. I don't care about if I'm behind from my peers, right? I'm definitely going to be behind by a lot if I return, right? Like let's say next semester, or maybe next 2 semesters. But it doesn't matter. As long as you have the spirit and you have the willingness to keep on doing the work and to keep on exploring those things that you really like, it doesn't matter even if the world around you falls apart, and you still do it because you love it, that's what matters. So, yeah. So, mhm. All right, guys. So it was great to see you. I hope this was a very informative and very useful session for you all. So I'm gonna leave because I gotta go work, right? So I gotta work. And but if you have any other suggestions for videos or something like this, if you like this, just leave down a comment. Leave down like a suggestion for a time and a day, so that I can make something like this again, and then maybe we could discuss it, right? Next time. Yeah, no problem. We could do a physics one exam review if I have time. Yeah, you just gotta like maybe after like at about the same time would be okay, right? Like at 8, maybe 10 p.m. if you're up. So yeah, I mean, actually, yeah, actually, not a bad idea. Recording tutoring sessions. Yeah, that's actually a good idea. I'm not sure about the privacy concerns there, right? I'm not sure if people. I might have to like blur them, blur the students. Yeah, the live is gonna be uploaded automatically, like after a few minutes. I think it's no, it actually takes like an hour or something like that. It's gonna be uploaded. Yeah. So, oh yeah, my Instagram guys is gonna be Marin Mats underscore excuse me, Marin underscore Mats. This is my Instagram. Marin underscore Mats is my Instagram, so you can check it out anytime. And you can text me for a suggestion, right? You can suggest any videos or something like that, right? Like what we just did, right? So that if you need help. Um, so yeah. All right. So all right, guys. So that's it for now. Have a good night and good luck on your exam tomorrow. Okay? Or I think it's Wednesday. Yeah. So good luck and take care. You can watch my other reviews. It's on YouTube. Right. I have like exams 1 and 2 and 3 for calculus 111. I never did the final exam for some reason. I think I was too busy. So this is just to compensate. All right, guys. Thank you so much for being here. I appreciate you. So I'll see you soon. Bye bye.